Dear students, welcome again to this class 8 Mathematics. In this section, we will do the sums 4, 5, 6 of exercise 3.4. Without delaying, let's directly come to the point. The fourth questions of exercise 3.4 is, name the quadrilaterals whose diagonals bisect each other. Name the quadrilaterals whose diagonals bisect each other. Diagonals of a parallelogram bisect each other. Rhombus, square, and rectangle are parallelogram, hence their diagonals also bisect each other like this. This is the diagonal, bisect each other. This is a parallelogram, diagonal bisect each other. A, B, C, and D. This is the parallelogram. The diagonal AC and DB bisect at O. So quadrilaterals whose diagonal bisect each other are parallelogram. There may be square, parallelogram, square, rectangle, and rhombus. Parallelogram, square, rectangle, and rhombus. All these diagonals of all these bisect each other. Next question, second part of question 4. Name the quadrilaterals whose diagonals are perpendicular bisectors of each other. Perpendicular bisectors of each other. The diagonals are perpendicular bisectors when all sides of a quadrilateral are equal. All sides are equal, then diagonals bisect each other. Like this. A, B, C, D. This is 90 degree. This is 90 degree. This is 90 degree. This is 90 degree. Perpendicular. So diagonals are perpendicular bisectors of each other that have their sides equal. So those can be square and rhombus. Square and rhombus. Next one, the quadrilaterals whose diagonals are equal. The diagonals of a quadrilaterals are equal if all the angles are equal. So all angles may be equal. If their diagonals are equal, then rectangle and square. The answer for the third is rectangle and square. Rectangle and square. Now bisect each other, quadrilaterals whose diagonal bisect each other. parallelogram, square, rectangle, rhombus, perpendicular bisectors of each other, the quadrilateral whose diagonals are perpendicular bisectors, that's the square and rhombus, and whose diagonals are equal, that is the rectangle and square. Now, question 5th, why a rectangle is a convex quadrilaterus? Convex quadrilaterals has all the diagonals inside the quadrilateral. Let's consider a quadrilateral. If these are the this is a quadrilateral. A, B, C, D. O is the point of intersection. The convex quadrilateral is a quadrilateral that has all the diagonals inside the quadrilateral, not outside of the quadrilateral. These diagonals must not outside of the quadrilaterals. So convex quadrilaterals diagonals lie in the interiors. So rectangle ABCD has 4 sides. Its diagonals AC and BD lie inside the rectangle. Hence, this is the convex quadrilateral. Convex quadrilateral. The convex quadrilateral is a quadrilateral whose diagonals are inside the quadrilateral. So this is the answer of question 5th. Now, this is the last question of this exercise as well as this chapter, that is understanding quadrilaterals. Question number 6. As shown in a figure, ABCD. A figure is given here. ABCD. This is the figure. ABCD is a right angle triangle. ABC is a right angle triangle. O is the midpoint of the sides opposite to the right angle. Explain why O is equidistant from A, B, and C. We have to explain. This dotted line are nothing but to help you only. So let's draw a right angle triangle. Let's draw a right angle triangle. Okay. This is the A, B, C is a right angle triangle. Then there is a dotted line that is to help you only. Okay. This is the diagonal, the point of intersection O. What you have to prove that O is equidistant from A, B, and C. It must have equivalent distance. Right angle triangle ABC, O is the midpoint. O is midpoint. To prove O is equidistant from ABC, It means we can state that OA is equal to OB is equal to OC. Let's draw a line from A parallel to BC. Parallel to BC. This is the line AD. This line is parallel to BC. Draw a line from C parallel to BA. Let meet at point D. Now join OD. In ABCD, as we know that AB is parallel to DC and BC is parallel to AD. Opposite sides are parallel. Opposite sides are parallel. Then ABCD is a parallelogram. Now it has been proved that ABC is a parallelogram. We know that adjacent angles of a parallelogram are supplementary. Adjacent angle of a parallelogram are supplementary. B and C, angle B plus angle C is equal to 180 degree. ABC is a perpendicular, hence B is 90 degree. C is 180 or C is equal to 90 degree. C is 90 degree, B is 90 degree, and because D is opposite to B, it's also 90 degree. A is opposite to C, it's also a 90 degree. So each angle of ABCD is a right angle. So ABCD is a parallelogram with all angles of 90 degree. So ABCD is a rectangle. So we know that diagonals of a rectangle bisect each other. This is the properties. So OA, now OA is equal to OC. OA is equal to OC, that is the half of AC. Similarly, BD is equal to AC. 1 by 2 BD or 1 by 2 AC. So OB is equal to OA. OB is equal to OA. So we can say that OA, OB, OC all are equal. All are equal, hence we can prove that O is equidistant from ABC. Now I hope you well understand this chapter, understanding quadrilaterals. In this chapters, at the initial stage, we have covered the concepts, full concepts of the quadrilaterals in this chapter. Then we have short out each and every questions of each and every exercise. I hope you understand it well. If you have any problem, comment on this video or send your mail so that we can send you reply in that mail. So please send your mail in a comment. Please keep watching our YouTube channel, HomeLearns. Thank you.